Today we'll be working on section 22.1. That's on page 843. You'll be doing numbers 1 through 6 and then 11. So today we'll be finding confidence intervals for population proportion. I know this formula looks a little extreme, but we're going to make it a little simpler just to show you this is coming from when we did our mean minus whatever our z-score was. Maybe we used 1, 2, or 3 times the standard deviation error. And remember, this is what we use for the standard deviation error. Same thing on this side, but plus that. So it's very similar. Okay, so we'll be using this equation right here. The only change really here, the major change here, is the z of c, and that you'll be using this chart down here. If they say 90% confidence error, you're using 1.645. If they say 95%, 1.96, 99%, 2.5676. Okay, so this is the equation. This here is the equation that we'll be using in order to find our confidence interval. Okay, the only thing you need out of here is p hat, which is our proportion, and that'll be given. And then we'll also need z of c, which is this here. And then we'll need n, which is our number in the sample. Okay. So everything here will be given. Let's look at an example. Isabel surveys a random sample of 80 voters in a large town and finds that 46 support raising property taxes in order to build a new library. So this means 46 out of 80 voters support more taxes for a new library. Find a 95% confidence interval for the proportion P for all voters in Isabel's town who support raising property taxes in order to build a new library. So the first thing I'm going to do is divide 80 by 46. What that's going to do is that it's going to give us our p hat. Okay, so 46 divided by 80, if you get a calculator and you type that in a calculator, hold on a second, 46 divided by 80 would be 0.575. Okay. Our number, or n, is 80 because they asked 80 voters. And then we're using a 95% confidence level. So our z of c is going to be, and we said for 95% was 0.96. Okay. So I'm going to plug that into the equation. So p hat is 0.575 minus 1.96 times, and that the full square root of 0.575 times 1 minus 0.575. Now you could do that ahead of time and figure this out, divided by n, which is 80. Okay. Then that's going to give your lower interval. So if I take this whole thing right here, this whole part right here, I'm putting in my calculator 0.575 times 1 minus 0.575 divided by 80, and then take the square root, I get 0.055. Okay, so I'm going to take that, multiply it by 1.96, and then subtract the original from that. Just like that. And then I will get 0.4672, so that's about a 47%. If I change it to percentage, I'm not going to do this all in green, highlighted in green. I'm not going to do that all over again. I'm just going to go 0.0575 plus 1.96. So I'm using the same thing. And then I'm using the same value, 0.055. that I figured all that out on my calculator. And then I'm going to go ahead and compute that. And then I get 0.6828, or about 68%. So my confidence interval is between 47 and 68% of people will say that they are in favor of supporting that. So just to recap, this is just what we did before. Once I find that, I do the plus and minus. The only difference is I'm using a different z's. That z part right there, the z of c, that's coming from the previous page, from this chart right here. This chart right here. That's where we're using that from. Okay.